Hi, I'm Joe, and this is Joe's Computer Museum. I am working on an Apple III Plus tonight, completely and utterly randomly, for absolutely no reason whatsoever. I figured I would share some of my work, because why not? I'm not on the YouTube as much as I used to be, and I need to do that or something. We got 4 people watching, 1-Bit Fever Dreams, me, and 2 other people. So hi, other people. EIBG is here. How you doing? I don't read French, or I don't speak French, so I'm thinking that 1-Bit Fever Dreams statement means something to the effect of, I want the JCM1 computer. He keeps saying that. I'm getting back to it. Random Apple III is the best Apple III. Yes, of course. So, little backstory about this little Apple III Plus. I got it in an eBay auction. And by Apple III Plus, I mean, let me check my cameras and make sure that they're not in weird states. And my deck is broken. My control deck, stand by. I have to control it with actual mouse cursor buttons. That would be this one. Yeah. So it's just the board. I got just the board by itself, but it was a new in-box board in theory. So new in box that the chips still have, there are the sockets under a lot of the chips still have these little retainer clippy doodles in the sockets. Like somebody got a blank board and stuffed it themselves or something. I don't know. The machine, of course, now that I decided to start the stream, is behaving itself. So but I will say one thing I did find. I've been working on this tonight, and my spouse was doing their laundry. And I wanted to maybe stream earlier, but they were in and out back here, and they don't like being on stream. So I decided not to stream earlier. So I was just sitting here poking around with the board, and just as the laundry got done, I found one of the faults. And I'll explain the fault here to you. Wow, my side cam is all the way over here. Stand by. Here's side cam. It should be on the other side of my recording camera. Oh my gosh, I'm about ready to throw everything on the floor. There we go. Cool. So we can show you this on screen. Yeah, great. So if I were to go to side cam, gonna work? Yep. So you can see it's working on the screen now. It's working perfectly fine. New in stock, yes. EIBG, it was new in stock, according to the person who sold it to me. The box was opened, but this board was pristine. It still had the protection clips over the RAM socket doodles, the pins. Bench cam. These pins that stick up when there's not a memory board in there, it still had the little plastic slided doodles to protect the pins on it. It was crazy. Anyway, so back to side cam. So you can see it's working now. The machine is fine. Well, fine. What I was getting was it was picking random video modes, just utterly random video modes for no reason at all. It would be running and it would go into 80 column mode, then back to 40 column mode. Then it would go to 80 column color text mode, then back to 40 column color text mode, then back to 80 column video mode. Then it would randomly switch into high resolution graphics mode. It was all over the place. Just literally just a freaking mess. It was a mess and jumping all over the place. It would be random. The other thing too is it would not detect that the keyboard was connected. So the Apple III detects the keyboard is connected by, I'll show you here. So keyboard here's got the keyboard light. This light is powered through a big power transistor, which sits right back here. There's a power transistor right here. That powers the light, and it was able to, the Apple is able to determine if the keyboard is connected by reading the state of that transistor to see if it's powering this light. can somehow detect the current drop, and that flips a flip flop, so it can tell if the keyboard's connected or not. Well, the machine, despite this light being plugged in and the keyboard being plugged in, it didn't think there was a keyboard in it, so it booted in its emergency demo mode, which does a built-in self-test and all this stuff. It was also detecting that the analog, the AD system was not working, which is what. Oh, that's my DAC. That's what that noise was. It was detecting that the what's it called? The AD circuit, which is the paddle circuit, which converts the paddle potentiometer into digital values. It was detecting that wasn't working either. I don't know, but I replaced this one chip and it fixed a lot of little glitchinesses. It took me forever to find that, and the reason is because this thing is part of the I/O circuit. I think I can look at the schematics. Which part of the circuit is it? It's part of the I/O logic circuit, but it generates timing signals, or it's like synchronization timing signals, for like 20 different things, for a whole bunch of different address locations. And so the machine can, if this doesn't work, the machine just goes weird. It just goes wacky. It doesn't know what, because whatever. So diagnosing it is hard, because is it a keyboard problem? Is it a video problem? At one point, it was turning the disk drive on and off, and ate my disk image that I was booting from. It's just doing wacky, random stuff. So replaced this chip and fixed it. This is an inverter chip. It takes a logic 1 and converts it to a logic 0, or it takes a logic 0 and converts it to a logic 1. I tested this in the chip tester, which I have this little chip tester pro right here. And it tests good, because if you test this once really quick, it will test good. If I put this chip in the board, put my oscilloscope on it and turn it on, it'll work for a while, and I can see it slowly start to fade out and stop working. So that's a little note to you all. Don't trust chip testers, because they're not always true. Oh my gosh, Trina is here. Shady Robot is here. Hi, Frank S. Sorcerer Stan. Hi, everybody. Thank you for stopping by. The machine still has a tiny little glitch, which might be because of the way I have it set up right now. And it's not exhibiting it right now. It's behaving itself perfectly fine at the moment. Stand by. I'm trying to get there it is. Is my deck working? Yeah, my deck's working again. So side. So what it was doing is it was detecting a key being pressed randomly for no reason. Just random key presses, even though I wasn't touching anything on the keyboard. It's not doing it now. It's behaving itself. I have a feeling this might be because I have an Apple III keyboard plugged into an Apple III Plus, and they're not quite exactly the same. So it's possible that this keyboard encoder is detecting phantom key presses at matrix intersections that aren't tied off on this keyboard. So they're just floating around. Anyway. Where's the best place to get a replacement enhanced badge from an Apple IIe? Try MacEffects. MacEffects.com. We can check it together. MacEffects.com. Thomas Armstrong is here. Hi, Thomas Armstrong. Acid Rain is here. Let's see. Do they have it? They have a lot of badges. They do not have the enhanced badge. I have gotten enhanced badges before from Reactive Micro, but he prints them. They're okay. They're not great. But they're like paper badges printed on an inkjet printer, so they're not like schmick. If you're not too worried about it, I mean, there you go. But if you are worried about it, I don't know. eBay, I don't know. I already have a clear 2E case, yeah. So, yeah, I don't have a line on that, unfortunately. MacEffects does have awesome, absolutely awesome metal replacement badges. So like in theory, I could take my Apple III Plus board, stick it in my Apple III case, and stick an Apple III Plus badge on it, and no one would know. And then I put the original Apple III keyboard encoder in this instead of the Apple III keyboard encoder, so it matches this keyboard. And again, no one would know. But I'm not all about that. So apparently, yeah. Side cam. It's working now. Like I don't have anything to stream about now because I got it working. I still do need to work on it though. I do have the speaker plugged in. Yep. So if I run the machine configuration test here, at the end of this test, it should tell me machine okay, system status normal, like that. When those last set of check marks go off. Yeah, but I don't hear anything. There's no sound count coming out of it. So we can dig into that a little bit. Did Geekenspiel make Apple II stickers? That's a good question. Let's look. Geekenspiel.com catalog. Yeah, they have lots of stickers. Ooh, cool. Geekenspiel. Ooh, maybe an Abu. Yeah, there's that peer pressure again. So let's do Apple. Let's just search for Apple. Nope, all they make is a QuickTime sticker. So yeah, nope, I'm sorry. Although if you ask them, they'll probably make one. They look like they make really high quality stickers there. So yeah. So let's see if we can diagnose what's going on with the sound in this. So let's go to screen mode, and we'll take a look at the schematics and figure it out. So here are the Apple III schematics. I want to start, since sound is not working, we'll want to start with the sound serial logic and figure out what's going on with this. And to do that too, I want to go into a different sound test to test all three different sound capabilities. So the Apple III has three different sounds it can make. It has what's called a hard bell, a soft bell, and then it has its digital audio. The hard and soft bell are generated by, if we go up here, they're generated by this right here. Those are just two 555 timers, basically. That's two 555 timers in a single chip. They're two 555 timers that are just wired up to make a beep noise, effectively. And then the digital audio comes out of this 6522 chip here, which then comes out these lines, goes down this way, and then goes into this amplifier circuit down here. So we can take a look at that and see if we can figure that out. Joe, what program are you using to look at that PDF? Old Adobe? Nope, I'm using Paint Shop Pro 8 from 1999. It is an insanely ancient program. It still works great. And it is my graphics editing program that I've been using for 1 billion years. David Starbuck is here. Hi, David. How are you? Yeah. So what I want to do is look at this schematic. And the reason I'm opening in my image editing program is because the schematic is a bunch of GIFs or JPEGs. So that's just how it is. So let's assume it's not the amplifier circuit. Let's assume it's nothing here, right? It's none of this. So that means we need to check the audio output. I know why it's not the audio amplifier, because when you turn on the machine, it makes clicky noises. So let's go right here to where all of the audio goes into the machine right there. And that is, let's just pick one of these pins at random. It is pin 1 of resistor pack 9, basically, right here. It's this right here. On top of that, I want to reboot the computer. Oops. In this different audio test, so we can do a different set of audio tests. So we'll do that first. We'll do a full system reboot here. There we go. This is the Apple III Dealer Diagnostic, which has the audio test in it is a little more, how can we say, comprehensive and robust. So we'll do that and turn that way so you can see it. We'll even zoom in. Sure, why not? So I'm going to go to the sound test and see if we get any sound at all. Yeah, we have no soft bell. No hard bell. And no DAC output. So that means we are getting no audio from either side, which then would indicate that the problem actually is the amp. Because these audio signals, as we can see from here, come from two different locations. They come that way and that way. And the only thing that is the same about both of those is the audio amplifier circuit, which is actually, why these are like increased color depth, 16 million. Cool. So that's this wire right here. Goes like this. And part of it goes into here. So there's actually three ways that sound is made. This is the wave sound. This is the hard bell, soft bell. And this is legacy Apple II speaker input. Joe said hard bell. Touch my bell end. Anyway, moving on. So we don't have to really worry about this. It's probably not that because the system tests the sound there. So yeah, image, we're going to increase that again and just save it so it's full color. So we really want to test it right here, right at that point, to see if we're actually getting audio. So that would be the positive side of capacitor 10, wherever the hell that is. I don't know. So let's go look for that. The positive side of capacitor 10. Where is capacitor 10? Where is it? It's on here somewhere. Stand by while I go back to my bench and declutter real quick all of the layers of insanity so I can get... Come here, you. Come here, you. This just needs to go away. Go over here where you belong. There. Go in your home. So where is capacitor C10? Where is it? I believe it's like way in the back somewhere. I have to hunt for it. Stand by. I don't know. It doesn't tell me where it is on the schematic. C10. There's C1. 2069. Knowing my luck, it's underneath here. It's underneath the RAM board where I can't see it. Here's C12. 13. I may have to dig into the bill of materials to find it. We can also look on another board that's not on the bench, because then I can get my eyes really into it. C10. Where is C10? Hello, C10. It's really hard to look on that board, too, because that has a black silk screen. Why does it have a black silk screen? Bob Darlington says, woo! Sloopy's here. Hi, Justin. What he working on with this Apple III? So, K-Mac, I am trying to make it work. I figured out one problem just before I went live. I had a bad 74LS14 inverter that was causing random video mode selection. Now I'm looking for the audio output driver capacitor so that I can check an audio issue that I have because it does not have audio. Aha! The audio capacitor is way the heck back here. So I can test that in theory. If I can get on it. Wow, the DAC is making noise. The other thing I can check is because the DAC is making noise right now, I can check pin 1 of RP9, wherever that is. That might be easier to get to. RP9, the DAC is one of these. RP9 is, here we go. So this 6522 is used as the DAC, and pin 1 is my output pin of audio. So I'm going to take a look at that. Gotcha. So that's good. So put my probe on that real quick. Oh, wow. Nice. Look. I moved things I shouldn't have moved. I made computer grumpy. Let's reboot. Don't touch pins you're not supposed to touch. Make sure it's booting. Yeah, it's booting. Good. Okay. Have you tried dropping it yet? Oh, David, you should have seen me earlier when I wasn't on stream. I was shaking the board and while it was on to try to make it work. Yeah. So we can go to sound, enter, loading sound test. Fun fact on this Apple III Plus, because I'm using a regular Apple III keyboard with it, if I put a regular Apple III keyboard encoder in it, the keyboard will work exactly as expected. Ron's computer videos, Kansas Fest. It's all about the Apple III this year. It is. Hi, Ron. Woot. Kansas Fest is the best fest. Yes, it's going to be all about the Apple III, and I'm going to be there, and I'm going to be doing the Apple III magics a lot. So I want to try to see if I can get you guys to see my oscilloscope screen. I'm still working on a way to get that piped into raw video, so I can just press a button. Don't have to point a camera at it, but one thing at a time. It requires me to either get a completely different oscilloscope or do some weird Python magic. So that's my oscilloscope. This is the audio input right here. You see it's going beep, 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 beep. You can tell we're making audio. Audio is getting into the amplifier circuit. So our problem is with the amplifier circuit. If I'm lucky, I've got one of those in stock. Oh, wait, I have a whole Apple III board over here I can steal parts from. Great. So let's find out what we need to do to fix that. So let's look back at the schematic. So the first chip we have to worry about is this capacitor, or the first capacitor we have to worry about is this right here. Or we need to make sure that this capacitor actually is capacitating and passing signal across and through all of this. So I do need to check a different place. Although the LM380, I can probably just go ahead and this is easy enough to replace. We'll just go ahead and replace the LM380 and see what happens, because that's an easy enough test. So where is the LM380? Go back to bench. The LM380 is right back here. It's this tiny little amplifier doodle. Yep. I'm just going to replace that and just see if that fixes it. It might also be this capacitor is just open and it's not passing any signal through. But we'll go ahead and swap the amp anyway, because why not? And I happen to have another Apple III I can do that with. There we go. So one of the easiest ways to test audio is to just unplug the keyboard. And when you turn it on, it'll beep at you. So is it going to beep when I turn it on? No beep. I still do not hear a beep. So, interesting. Very interesting indeed. Why would it do that? I don't know. That's probably that capacitor then, or some other part of the sound circuit. So let's look at, I want to look at pin 1 again here while we do a reset. Pin 1 of this resistor pack and see if we get a beep. Yep, you can see that. You can see those little squiggly lines. It's hard to see, but basically the signal goes all square wavy. Beep right there for a half second. So that's working. So let's look at the input of the amplifier. You spin me right around, baby, right? Does your oscilloscope have a web interface that shows the screen? If so, you might be able to pull that into OBS as a web source. No, my oscilloscope does not. The only thing you can do with this oscilloscope is use a special piece of software to fetch a screen grab of that screen. However, there is somebody who's made a whole chunk of Python code that will like fetch, convert, like it's super high speed. And get you basically a 15 frame per second kind of video thing or something like that. So yeah, this is a little cheapy scope. It is insanely high featured for being as cheap as it is, and for the fact that it has special firmware installed. Shh, don't tell anybody. But it doesn't have video output. So let's do a thing. So I need to test the audio. Like right here, right? On resistor R34 after it goes through all of this stuff to see if it goes through this capacitor. And the reason I'm testing it on this resistor because I can get to the legs of the resistor without flipping the board over. And flipping this board over while trying to work on it is basically impossible. It's not entirely impossible, but it's pretty hard. So I need to find resistor 34. You can't see a dang thing I'm looking at. This right here. I need to find this point right here. Resistor 34. Yep. To make sure we're even getting signal into the LM380, which I'm pretty sure we are because we swapped it and it's still not making noise. Resistor 34 we need to look for. So that's going to be up in this area somewhere probably. Because like I'm seeing 38s and 37s and 39s and stuff all in that area. Yeah, 36 is part of that circuit. So I could probably also test it there. I could also probably just test pin 2 of the LM380, but that's after a resistor, which means it'll be a really muted value, and I don't want to do that. So where is resistor 34? Hello, resistor 34. Where are you? Car 54, where are you? Is that a loop? There's also an inductor in there. It looks like. Or something. There's some other thing that has a lot of pins that it goes in pin 19 and out pin 2. F3, a filter of some sort? Hard to say. Because you can't read the schematic. Looking for resistor. Haha, it's right up here. Resistor 34. So we can plug the keyboard back in, get it booted up, and get it making noises repeatedly so we can see signals. That's what we're going to do. Boot. Boot-a-doodle. Apple III dealer diagnostic booted. Flex the board will work most of the time. Another damn Apple III. At least someone is keeping them alive. $20 from Mike's Mac Shack. Oh my gosh. That paid for the shipping for the board. Thanks, Mike. Woot. You get double woots. Woot, woot. Cool. Bye, Trina. Cats are making the sleeping look good. I don't blame you at all. See you later, Trina. So let's go into the sound test and get it to make noise-a-doodles so we can check it on the thing. Yeah. I am pretty sure our problem is the capacitor, the two components just prior to that, because if we look at this, that's on one side of that capacitor, or one side of that of R34, and the other side of R34. There's nothing. What is this other? What's on here? I don't know what that data is, but yeah. So that's nothing. So I'm going to see if we can probe this capacitor. Is this the external speaker? Let's check the external speaker connector, which is right here. What's on it? Nope, it's dead. What's on this other pin? That's ground. Nope, that's not ground. That just means I've got a bad ground. Stand by. Why do I have such a bad ground? Okay, well, anyway, if the external speaker connector, if we look at it, you can see we're getting signal there. Beep, 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 beep. And the next place that goes to is the resistor. It goes immediately next to the resistor, R34. And R34 has nothing on it. So there's no connection from the external speaker connector here, not the internal speaker connector, the external speaker connector, to that over there. Interesting indeed. So now we got to flip the board over and take a look at it. Yes, we do. If you leave it in the woods, does it make a sound? Sound in Braille isn't good. Yeah, no. No, it's not. So let's flip this over, which is always a pain in the butt. Disconnect all of the things. It just makes it easier on me. There we go. So basically on this board, between here and here, there's no connection. It just disappears. So we're going to give it a quick visual inspection. Oh, let's see. Oh, say, can you see? The external speaker connector is right here. And it goes right over here directly to R34. Exactly as it should. So we've got a bad trace on the bottom of the board or something. Not a lot of room on this bench for this gigantic logic board. Stand by. Moving things around. Failing to move things around. Okay. Let's take a look. Okay. So we go into... Boop. It's an Apple III, more like Broken Dreams. Broken Dreams. You're funny. So let's take a look here. So this is the bottom of the board, obviously, and this is the pin on the external audio jack I was checking that actually has signal coming off of it. And this is the other side of that resistor. So there should be audio signal there. And there isn't. And that trace, honestly, to me, looks perfectly fine. So we're going to have to get like creative or something because I don't know what's going on. Does not look to me like there's anything wrong with that trace at all. So I'm going to do a quick reflow of this pin, of these pins, just in case. And then we're going to do a continuity test. Doesn't like that solder, does it? It doesn't like it. I had a bad connection here. Add a via, maybe. Because that signal comes from the top side of the board through that via over to the bottom side. So yeah. Just run a bodge wire and see if it works. I know. Just chill out. I'm on it. Put that over there. Boop. Okay. And now we get to go through the whole process of getting it all connected back up together. That goes there. Floppy drive, i.e. my W drive I'm using for testing. Speaker. Keyboard. Keyboard. How quaint. And video output. All right, that should just boot. Yep, it's booting. Also connect my ground lead. Dealer diagnostic booted. There it is, and I can go down to the sound test. No sound out of the speaker. We're getting sound out of the sound pin. Are we getting sound out of the sound pin? Interesting. Which pin is it? The middle pin. Hold on. I think I figured it out. Stand by. I think I figured it out. Everybody, look at my shoulder. I need this. I think I know what the problem is. Fixed it. You hear it? I'll show you what it is. I'll show you what I found out. You look very carefully right there and you tell me what I figured out. Tell me. Tell me. You tell me. You tell me. Have you figured it out yet? You got it? I'll give you a second. Bob Darlington. Bob Darlington is correct. J11, it on the original Apple III is a actual phono jack connected, is like on the board. The Apple III Plus has an external header wire that goes off of the board onto the back panel of the computer. So this board running outside of the machine doesn't have J11. So that means that this wire and this wire have no switch to connect through. So the signal has nothing up here to go through like this. So I just put a jumper over the two pins and it worked. Aha! So that's good. Sound works. Now, sweet. That is awesome. So let's do some other tests. Let's do some other tests. Why not? Let's do the standard video test, which I don't think it'll work because I don't think the spacebar works with this keyboard encoder. I might have to change the spacebar or change the keyboard encoder. This video test takes forever to load. There it is. Yeah, I can't continue because I can't press space. Testing aborted due to test failure. Yep. Okay, cool. I knew it all along. I just wanted to see if you would figure it out. It's an Apple III, so I'm sure it has RAM issues. Oh, you might be surprised. It has already passed another test. In addition, this RAM board doesn't go with this RAM board goes to a completely different Apple III, because I bought this Apple III without a RAM board on it. It was also missing this chip right here, but I just have those, so I just threw it in there. So yeah. Let's do a cool thing. We're going to switch the keyboard encoder over to the JCM1 keyboard encoder, because then that'll make the keyboard work. That'll convert this Apple III Plus keyboard encoder to an Apple III keyboard encoder, which will then make it match the keyboard I have plugged in. Yes, it will. Yes, it will. Let's get this swapped out. I need to wear my static wrist wrap for this because this is an original keyboard encoder, and they are insanely static sensitive. That is out. This keyboard encoder is in a standard Apple III mode. There we go. And in theory, that will work. So we're going to go to side mode. I think the Apple III has design engineer issues. Oh, it's got all kinds of issues. How do you like my nice little Trintron monitor here I picked up? It's cutie patootie. I like it. So let's go down. Let's do our video test. The schematics look like spaghetti to me. Yeah, they are. Yes, they are. You're not imagining that. They actually are spaghetti. There we go. This video is being piped out to the television from my Apple III video encoder, which means that we're getting a proper color signal out of the Apple III. Normally, the Apple III doesn't have color video on its output. So spacebar. Hey, look at that. That's good. That's good. That's good. Looks good. Looks good. Looks good. Looks good. Color bars are beautiful. Ignore the refresh rate there. That's just a refresh rate thing. Can I change the... Yeah, if I change the exposure, it will stop flickering. Text. Yep, blinky and inverse and all that. Apple II is fine. Sarah 40 column mode. Look at all the pretty colors. Look at all the pretty colors. Just trying to get it to lock the refresh rate. Stand by. There we go. Yep. And we hit spacebar, 80 column text, which you can't see on the television because it doesn't really have the proper resolution to do it. Sloopy Malibu, am I going to RGB mod it? Oh, yeah, probably. Yeah. Abso-freaking-tootly. We know the sound works. Let's do the 5-volt RAM test. Since somebody was like, I'll bet it has bad RAM. Can I get some war colors? I believe it was Mike that said it has bad RAM. Bell, I'm about to prove to you it don't. RAM map indicates a 256K system. That is correct. Testing RAM. Sweet, delicious Coca-Cola Zero. Hi, Adam. Testing bank 2, bank 3. Testing all the banks. Jane and Michael Banks. Get that reference? Zoom, zoom. I had my compressed air can out earlier because I was doing heat test of chips. Ha-ha! It passes. It passes. I can't run the disk test. We can run the keyboard test, which will probably fail because this keyboard's got 1 or 2 bad keys. If I can get it to do the thing. Boop, boop. Yep, C6 didn't work. We have to do ZXCVBN and blah, blah, blah. Cool. And then we do left, right. And we already did the up and down. So we need to do left shift, which is shift 2. Right shift, which is shift equals. And control A checks control. And then space. What are you looking at? You are looking at the Apple III dealer diagnostic we're running on the Apple III Plus. Alpha lock once. Press space bar and keep it down. Without lifting space bar, hold down both Apple keys. Release all keys and then press and hold the solid Apple key and then press and hold down space bar. Test passes. Press any key to test. Sure, I did that. David Starbuck is quoting the escape velocity of Earth. Okay. So that works. I know the ROM test will work because it has a standard ROM in it. ROM 3 final test. ROM passes. Sure does. Can I write Apple III disks using an Apple II and a floppy EMU? Technically speaking, you should be able to do that, Adam. You may have to do it in block mode or raw mode or whatever you want to call it. ADT works really well as for doing that as well. Christian Iverson. There's an Apple III. You've completely missed a generation. Oh, Christian. I am so sorry you missed the Apple III generation. It doesn't surprise me seeing how the first 14,000 that they sold were all recalled for very, very bad problems. And all told, they only ever sold 80,000 Apple IIIs. The vast majority of those were installed at Apple's campus as data entry terminals because that's all they ended up being good for because they had lots of hardware problems. That said, if you can get past the hardware problems, the Apple III is a phenomenally powerful machine for being released in 1980. 16 color graphics, 560 by 192 graphics modes, lots of really cool addressing modes, really cool bank switching. It ran at 2 megahertz while doing processing. It had proper DMA that actually functioned correctly. It had 8-bit digital audio, so you could play like wave samples. And it had really intelligent scrolling capabilities to be able to scroll the screen up and down really, really fast compared to doing so on the Apple II. It also had an Apple II emulation mode, so you could run a lot of Apple II software that would work under like a 48K Apple II Plus would work on the Apple III if you booted it into emulation mode. So really cool stuff. It was designed as a business computer and failed miserably. And you can go read about all the history on it. So now I want to boot to the Apple III Confidence disk, which is a different it is a different set of diagnostics. It's very similar to these diagnostics, but it has some different other features. So I'm going to go ahead and do that. We're going to boot to the Confidence disk, which boots way faster and runs way faster. So machine configuration. This is what I really, really wanted to do because this test has a really cool audio test, if you can hear it.
I'm okay. Machine status normal.
Did you hear that? Did you hear it talk? Sorry about the noise just there. I'm going to put my microphone right next to it, and we're going to run the test again so you can hear it.
I'm okay. Machine status normal.
The machine actually tells you it's okay in a voice. Ghostbusters, yes. Ghostbusters! Need to plug my microphone back in. Apologies for loud noises, because I'm just putting my mic back. Boop. There it is. Cool. My serial number is 105528. My serial number is... This serial number might be 1. I don't know. It was a board in a box. Here is the memory test. This Apple III memory test is better because it is continuous. It will sit here and just run and run and run and run and run and run and will never stop. It will never stop at all, ever, until you press a button, which means you can stress test the RAM. Last time I ran this test with this memory board, it ran for something like 500 passes because I ran it overnight. Delicious Coca-Cola. So we're not going to sit there and run that forever because that's boring. Here's the video tests, which again are very similar to the other video tests, except these are much faster. Hit return. Into video tests. I'm afraid to turn on my Apple III again before I check the reefa caps. Absolutely check your reefa caps. you can't own a cat, or you can't expect the test to run all night. Yes, exactly. So there's another test on apple3.org. We're going to go there real quick and grab that test disk. So this is apple3.org. It is a really cool place. It is like the place to go to do anything Apple III. And there is an Apple III Plus dealer diagnostics disk right here. So I would like to download this disk and try it. Maybe. So we're going to go ahead and do that. We are going to try that. Boop. I want to see what this other test disk looks like because I've never tried it before. I replaced my power supply with a reactive micro. Works great. Plenty of power. You mean like that one? Right there? This is my repairing old Apple's bench supply. It is a reactive micro supply with a replaceable power pigtail. As you can see, I have this one labeled for the Apple III, but I have one for the Apple II and the Apple II GS and an LC2 and one other machine that I can't remember, my Franklin. I just replace the connector off here, plug it in, and it runs everything. I'm going to need a new badge for my unit. Yep, MacFX has your badges. That's where you go to get your badges. Apple III Plus Diagnostics. So we're going to take that and put that on here in my Diagnostics folder. Sure. We go here and we eject that. Things are left alone if I don't use them, yes. Do I have an SSI 263 chip? Oh, I would love to have that. Hasn't somebody cloned that yet? I thought somebody cloned that. So we're going to boot this other disk. And I want to see what it looks like, because I've never booted this disk before. It beeped at me. I don't know if that means anything. It's still loading. It's probably exactly the same as the first one, just with slightly different, slightly changed tests. It looks exactly the same. Ooh, it's got the calendar clock test, because this has the clock chip in it. So we're going to test the RAM. Works great in a phaser. Yes. Or just drop it. I've already done that. Trust me. Yep. We already know this works. Missing enter key and switch. Well, good luck with that, sir. Good luck figuring that one out. All right, I'll let this run. Do I have a thingamaboob? I don't know. Do I?
Thingamaboob.
Testing bank 6. I have a doohickey. Does that count? Mike has a bright pink 6-inch doohickey. He knows what I mean. RAM test passes. Yes, we know it will. Sure. Great. Are you done doing what you're doing? Are you loading? What are you doing? Great. So I know that'll test. Let's check the calendar clock test. I want to see what this looks like, since this one actually has a clock chip. Clock chip test. Clock chip passes. Yay! So I have a working clock chip. Awesome sauce. Cool beans. I want to see if the sound test is any different. This is mostly me just playing around with this disk now to see what it's like. CO30 sound. So it's naming them different, so you know the actual address area where the sound is coming from. Interesting. Is the clock Y2K compatible? Probably not. Mike, I'm talking about the bird, buddy. I'm not talking about Frank. Is the clock Y2K compatible? That's funny. These video tests are probably identical. I'm just curious. I like to see them. Do it. Do it. Joe demands it. Still loading. I can see the disk loading here. Yay! Video interlace test. That's interesting. I don't know what that is, but that's a new test, and I get a line on the screen, whatever that means. I don't think the interlace test works. Can you overclock the CPU? Acid rain. No? Maybe? The Apple III already has what I would call a dual speed clock. When it's doing CPU stuff, CPU-y stuff, it runs at 2 megahertz. And when it's running input-output stuff, i.e. stuff with the slots or the floppy controller or any of that stuff, it runs at 1 megahertz. And it will switch those 2 speeds internally automatically. It just does it just blah, 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 as it needs to do. Perhaps, maybe in theory, you might technically be able to overclock the 2 megahertz side of the clock, and it might work. But I don't know. I would have to severely study that if I wanted to do that. And I have a feeling you would have to overclock it very similarly to an Apple II, where you would have to be watching very carefully the bus timing, bus arbitration, RAM timing, having a cache, blah, 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 in order to do that. The biggest problem you're going to have is probably with the RAM interfacing, because you could probably replace all of the chips on the lower half of the board here. This one, this one, this one, and this one. These are the ones that are, these 4 are the ones that are truly CP or speed bound. These are all 2 megahertz parts. But these, you can get all 4 of these chips aftermarket, brand new. You can get a 14 megahertz version of all 4 of these chips. So that would remove that problem. And then the next problem would be the RAM. If you overclock this, while it's in fast mode, the RAM is running at that speed too. Bye, Frank S. Smash that like button. Don't forget to subscribe. Yes, do it. Do it. Do it. So because of that, you're overclocking the RAM too. The RAM, this RAM does have some wiggle room for some speed increase, but not a lot. You could maybe get this RAM up to 4, but then you'd be running into issues. You also start to running into issues with the timing circuitry down here. A lot of these timing circuits here are very clock sensitive. So that would be your worries. It might just work though. You might be able to overclock it at 3.57 and it might just run. Because the video circuitry, the I/O circuitry, and everything that's critically timed to a specific speed is all timed off the 1 megahertz clock, and you just leave that clock alone. You just don't touch that clock. So, yeah. Let me put this amp chip back in this other board standby. There we go. I don't know. Sounds like a challenge. Yep, a challenge for future Joe. Present Joe already has plenty of stuff going on in his world. Now, the final thing I'm going to do tonight is I want to test something really, really cool. So I have the Titan 3+2 and 3+2E board sets that Titan Engineering or Titan Industries or whatever the name is. They made that'll turned an Apple III into an Apple IIe, like with near full compatibility, with a couple very, very, very small glitches, but it allowed you to use anything that used 16K language card space. It allowed you to use anything that used full 128K of RAM. In theory, I think it even will run Apple Apple II desktop. I think. Don't quote me on that. It will run ProDOS, as far as I know. I still haven't done full tests on that, but I'm pretty sure that's all the case. But the one thing I haven't tested is, will the Titan card set work in an Apple III Plus? Somebody asked me on a stream a couple nights ago if that was the case when I was talking about that. It might have been Retro Repair Roundup. I don't remember. So it might have been Steve's stream last night or whenever he was working on the Quad 840 AV. I don't remember. So I wanted to actually test that. So that's why this is on the board. Or on the bench. I wanted to get this board working so I could put the Titan set in it and see if it worked correctly. I don't know. No plan, no purpose. Eric's Edge. Will it run Apple II GS software? Ha 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 ha. Yeah, I know that's a joke. Will it run Crisis? Ha ha ha. I know that's a joke. Yes. Will it run Crisis? No, but it will eat my tears that I have cried. So let's go to the bench here real quick, and we're going to go ahead and install those cards in this machine and see what happens. I mean, right? Why not? I'm thinking that it will probably work just fine because the Apple III Plus and the Apple III are electrically identical. They're the same machine, basically. It's just the Apple III Plus has a better design physically, is less prone to weirdness. So we need to pop the video chip out. This is what helps address the timing for the video modes. Little state machine. This board goes in slot 2. This is the 3 Plus 2E. And then, of course, this needs to go this way. First, stand by. This is a little tricky. There we go. Yep. It goes in there like that. And then this board goes in here. But before we do that, there's a little adapter cable that has to go on here, which I thought I grabbed, and I think I don't have. Stand by. Yep, here it is. This is the 3 Plus 2 cable. Which goes to the 3 Plus 2 board, which you were able to buy by itself, which just got rid of the Apple II Plus limitations built in and made it a full Apple II Plus. But this makes it an Apple IIe. So it's got like all the extra. It's got double high res and all that cool stuff. So, in theory, with those boards in there, this should do a thing. I turn this on. Yep. So if I go to the side, you'll see that it's still booting properly, even though I removed the video chip. That's because the 3 Plus 2E board is doing the video state machine-y stuff. Right? They integrated that state machine information into this board with logic, so that they could get away with, we didn't steal your ROM data. We re-implemented it. In a future version, I maybe I'll just design this, get rid of all of that logic chip and logic crap and just say, hey, put this directly on the board and it'll do all that for you. Anyway, so the one thing I wanted to do is I want to boot to this other disk, which is this disk here. I'm going to reboot. Maybe. Machine is not behaving. We'll do that. There we go. So this is the 3+2E emulation disk, which allows us to do things. So change to E emulation. So if I were to press 2, I can do things like turn double high res on and off and stuff like that. So I'm going to leave double high res off, because then I can hit 3 to start the emulation. It's now an Apple IIe. Emulation disk, insert Apple IIe disk. So let's, I have this disk. PR6. 6 key. No. 6. Boot. It's not liking me. So maybe this means something. I have a feeling it doesn't like the Apple III. Or the Apple III Plus. It's just stuck. It doesn't want to boot. It don't like me. It got stuck in a weird mode. Booting up to the disk again. Ron gave me a super sticker. Ron's computer videos, 99-cent super sticker. Woot! Thank you, Ron. You have a 5-volt memory card in this thing. Yay! Is there room on either of those cards to attach on a normal card slot rail? No. Nope. Adding another $500 to a $2,000 computer, you can emulate an $800 computer. Yep. Absolutely. Welcome to the Apple II world, or the Apple III world. Let's see. I want to start a different Apple II disk. So, let's go up there. Let's try that disk. It's booting that disk fine. MECC Computer Inspector. What is that? Huh. Let's go to that. Normal text and graphics. Look at that. And why? It's running on an Apple II or an Apple III. You can also tell my colors are wrong. And I don't know if that's just a tint problem with the monitor itself, or the Apple III needs an adjustment, but it's probably the monitor. We can test that by testing on a different monitor. So let's do that. I have another one up here that we'll just switch over to real quick and see. Oh no, that is the Apple III. The Apple III's colors are wacky. Look at that. I wonder what that could be. Could that be this thing right here? That's the clock tuner. What is that? What does that? I wonder. Interesting. It's out of phase, right? It's not quite right. It's hue bent. Hue bent. In theory, I could also do this. Yeah, there you go. That's better. That's better for showing you guys what's going on. So I'm going to try something else real quick. I'm going to try true RGB out of my GONBEZ adapter to VGA to see if that does any better. Hopefully I don't short anything out or explode anything while I'm doing this. I shouldn't. So that's that. And I need this to go in here. Like that. And now I need to change my monitor input to PC and see if the colors are better there. And it's completely black and white. That's not correct. Wait, that is correct. I take that back. Aha. So here's also a thing to look at. So this is the RGB coming out of the Apple III. I'll tell you about the chip here in a second, Adam. This is the Apple III RGB in Apple II mode. It doesn't actually display color in out RGB. And that's an intentional limitation of the Apple III. Black and white is always correct in the 1-bit fever dream. So you can't use this as a reference. If you have an RGB monitor that you're using with your Apple III in Apple II mode, it will always be in black and white. That's just how it is. You can't get around that, apparently. The only way you get around that is the way I've done it, which is this way. But we've got a hue tint problem, which you can see is slowly getting better. Adam says, my motherboard is missing a chip at the front left. It's the second chip in at location B3. That's the clock chip. That is normal for that to be missing on a non-plus. The chip that is a B8532. So if you can find one of those. It's the same chip that's in the Ultra RAM 2 for the Apple IIc. Exact same clock chip. So you could use that chip, and that would be a thing. So I wonder why. I don't know why the color is not correct in Apple III mode or in Apple II mode through the external connector like this. I'm not sure. We can check it in, let's check 80 column text. Oh yeah, it looks fine. Ignore the wobbling. That's just my setup here. That's not the actual Apple III making that wobbling. I want to, let's do this, machine identification. An enhanced Apple IIe with 128K of memory. It doesn't know what it is. Here's one other thing. I wanted to test the color video in Apple III mode again. If I can get it to boot. I may have to power it off and back on to change the state to get it to boot back in Apple III mode. Yeah, cool. I wanted to test the color in Apple III mode and see if it looked okay. And just see if that's an artifact of, again, ignore that squiggling on the screen. That's not actually on the Apple III video. That's my capture system. Yeah. So that's what it's supposed to look like coming out the NTSC. That's what it actually looks like. It's color shifted. It's not correct. Oops, I didn't like that. That looks okay. But it's supposed to look like that. The reefa in here is half exploded. Yeah, I believe that, Adam. I totally believe that. Super high res, which is just black and white. More black and white. Color high res. It's not quite correct. I mean, it kind of is, but color bars. Yeah, it looks hue shifted to me. Yeah, you can tell right there, green lower left isn't correct. The orange is pink. Mm-hmm. Yep. It is hue shifted ever so slightly towards in the red direction. Yep. The blue looks green. It's supposed to look like that. Yes, that green is supposed to be muted over on the far left side. That's how the RGB encoding is through this adapter. But that's wrong. That is very, very, very wrong. Oh, shift, Hugh are joking. Ha ha! Now we get to get back to Cayman on day 1 in Florida to solve that audio. Yep, put a jumper on pins 2 and 3 on the audio jumper in the back left corner. So how do we adjust the hue? Is it a frequency thing? I don't know. I need to go to the video logic, which is here, and look at how the video is being generated. All right. So we go here. And NTSC, this is the actual video that we're looking at on my machine. This is what generates the colors. Or not the colors, but the luma, the brightness. The phasing of the bits coming through in here, wherever it is, through these two here. This is the bit stream. And these help do phase shifting. But C3.5M here, this is the color burst signal. And I think that it is somehow being phase shifted, but I don't know how. So that's pin 1 of K8, huh? Well, let's look at pin 1 of K8 on the scope. Let's do that. So pin 1 of K8. Where is K8? Under these chips where I can't get to it? 8K. Back here. It's this one? LS11, right? Pin 1. Okay. It looks like a perfect 3.57944 megahertz signal to me. Pin 2 color is color gate, which is what's telling it when it should be kicking a signal out. Wrong pin. And if I zoom out, you'll see it doing it once every 14 kilohertz or so, 15 kilohertz, which is normal. Only at the beginning of the line. That makes sense. And then pin 13 is color killer, but that shouldn't be engaging. So that's this 16 pin chip, 7 pin, pin 13 is this one right here. And that's just high all the time, which it should be. That makes sense to me. Interesting indeed. It's coupled to the 100 picofarad capacitor at C5. Interesting. We adjust hue, but by giving him a sense of individuality and send him back to the Borg collective. You're funny. C5. Gets coupled through C5 with L1, which softens it. So it could be one of those. Where is L1? L1 is this big chunker right back here. I wonder if I do a thing where I synchronize to that pin. This is tricky poopies while it's running. I do it this way. It's less likely to cause a glitch. Stand by. I'm doing craziness. This may or may not work. We're going to do this with the machine off. Try it again. Stand by. I'm trying to get clipped onto this one pin so I can use that as a sync signal for my testing. So we can do that. Yeah, there we go. Cool. So then now I can use this other thing. Video tests. The other pin I want to test is L1. Right there. That's a good color signal. Yeah. Joe, is it safe to remove the 22 UF REFA and run this? I'm not sure if I have that exact part in stock. The 22 UF REFA, let me double check my actual power supply. I'll let you know. Stand by. A real Apple III power supply. Yes. So face cam. Adam, if you're talking about this one right here, yes, you can remove that and it won't hurt a damn thing. Just yank it out. That looks like an Apple III power supply to me. Yes, it is. Yes, it's basically just a filter cap. Is there software that is bespoke to the Apple III? Lots! And by lots, not much. Yes, the Apple III has its own operating system, its own programming interface, and its operating system is very similar to the Mac insofar as the operating system built for the Apple III is very, very similar, or is very, very tied to the hardware like it is on the Mac. So, yeah. There we go. That must be the coupled side. Yes. So I'm trying to see where this is phase shifted. and why. I have a feeling they just don't care. Stand by, I'm just looking at some things. And then we can go to channel 2 and select the scale. There we go. Apologies for the noise. It's just noisy. It's just how it is. That's better. Cool. There we go. And it's, I mean, there's nothing really you can do about it. Just is the way it is. You adjust the hue on your TV is how it's done. Because it was an afterthought, I think. Okay, cool. So I'm going to show you what I found. I want to switch to this camera, and we want to zoom in on this scope. Okay, so the yellow trace, ignore that for now. I'm just using that as a trigger so it will lock to a specific place in the signal. This is the video signal, basically. The blue trace is the video signal. 0 volt position. This is the horizontal sync pulse. And then this right here, this little squiggle part, that is the color burst, which is used to synchronize the television's color timing to itself. Now, depending on the phase relationship of this frequency to the pulses that come on down the train, which we might be able to zoom out here. So the phase relationship between this squiggle right here and these squiggles are what determine the actual color that is on the screen. If you want to more details on how that works exactly, you can go back and look at my JCM1 computer series. I'm trying to get a little closer in here, but a little less blurry. Stand by. But basically, if you change this, say this is the color burst frequency, and these are my pixels. If I slide these pixels in relationship to the peaks of these pixels in relation to where the peaks of the actual color burst are, that's what actually changes the color, right? If the relationship between this color burst and these dots is off for some reason, the back porch is right here. Right here. If this is off for some reason, that phase relationship is wrong. The color will be wrong. This phase relationship between this and this right now on this Apple III are at a fixed offset from each other. They just don't match. So what that means is what the Apple III thinks it's putting out as a color is not quite what it's supposed to be synced to here. All of these pixels should be shifted over to the left, probably by 1 or 2 4 megahertz clock cycles, just a tiny little bit. And that would fix the color problem on the screen. That would make those colors work correctly. That would make that orange actually orange instead of pink, because it would shift it more towards the yellow end of the spectrum. And that's it. Why that phase relationship is off, I don't know. Because there's not, that phase relationship is generated entirely by logic. And we can look at that logic by going over here. So this is the color burst signal. and these are the actual pixels. So the phase relationship between this color burst and these pixels is fixed by the data train, by the literal low-level timing of the machine. So unless there's like one gate that is off by like 1 or 2 counts, but those counts don't actually matter for the operation of the machine, that's the only thing that could make this wrong. Literally, that's the only thing I could think of that could set this off by a slight phase offset. Short of maybe, and it wouldn't even be this part of the circuit right here, this L1 and picofarad, this inductor and capacitor. Basically a noise reduction circuit and a cleanup circuit. These can affect that phasing, but because both the color burst, which is right here, comes through here, and the actual pixel data comes through here, they come through those same two things, both will be phased identically by this part. So that's not the problem. Is there any chance that a part of the circuit is getting weird impedance to lag, make it ahead? Yes. Possibly. If it is, I'm trying to think of where it might be. It might be that right there. I'm just trying to think of how that would, why, when you think about it, the bit train is coming into the base of this transistor to be amplified. So like input out, and then that means this signal is actually going up through and then through this resistor bus and out. But it's also like tied to ground here for noise reduction. And then you've got the 75 ohm there to provide bias. I don't know. Maybe your capacitor is affecting different colors differently, maybe frequency dependent impedance. I don't think so, because all colors on NTSC are generated by a 3.5 megahertz carrier signal, period. There's only one frequency you will ever see in an NTS signal. It's 3.57 as far as the colors go. It has to be 3.57 or the colors won't come, they won't show up. That's how NTSC works. And it's shifting, when you think about it, the only place that the shift could be happening, if the shift is happening anywhere in this part of the circuit, it's going to affect color burst and the bit train at the same time. Because in both cases, the bit train is being pulled through this, down to ground, and also through this capacitor, pulling through this capacitor. This is just noise filter. That's all that is. Filtering high frequency, whatever. This is the same thing. It's coming through this, and it's being filtered down to ground, and it's being the color train is coming back up through this 2K resistor and through here. This resistor is not going to change the phase at all. It won't have anything to do with phasing. The only thing that's going to do that is an inductor, which I could try literally just cutting that out of the circuit and see what happens. I mean, I can just snip it. I don't think it's, but again, like I said, if it affects the phase, it'll affect the phase of both this and the bit train. And it's the relationship between these two. Where the color burst phasing starts or ends doesn't matter, as long as it starts and ends in lockstep with the bit train. You can move the entire phasing of that whole thing left and right as much as you want on every single line. And as long as this matches this, the colors will show up right because the TV locks onto it and does it. And to answer Sloopy Malibu, this is why so many computers run at these frequencies. Yes, they are all multiples of the master NTSC timing frame reference of 14.318180 megahertz. Because it's easy enough to just run the whole machine off of the NTSC video timing when that's the TV, when that's what you're running video out to. Because then you can time everything in lockstep and you avoid frequency interferences and stuff like that. And I mean, frankly, to be honest, if you already have a crystal on the machine, making your megahertzes at the TV megahertz frequency, you don't have to have another crystal on there. You just divide it down to what you want. Right? Right. With the exception of the Apple II and the Apple III, which have their weird 1.023 megahertz funkiness that still is in lockstep because it's like 3/4 or something, or it's like 3/8 of the NTSC or something. I don't know. It's things. And also 7.16 is NTSC times 2. Yes, it is. Yes. So it being out of phase is like the whole thing is just out of phase. All of it. Or not all of it. The bit train is out of phase with the color burst. By how much? Wait a second. Where's your vector scope, Joe? I don't have one. If I had one, I'd be able to solve the problem pretty easy. I'd be able to see, oh, it's exactly this many degrees out of phase. I'm thinking, this is a complete random thought. This is a color burst. This is the actual color burst signal. See, it has a bar over it. It's like a negative going signal. That means it has a complement somewhere, maybe. If it's being negated and passed through. Yeah, see, here it is right here too. That's what tells this. It's one of the chip selects for this chip. That's what tells it to output signal. If it's being negated during generation, somewhere farther back in the chain, and that negation, if like, I don't know, the gate on that inverter is shorted, so it's literally just putting out the same signal as getting in, that would put all of the color timing off by 180 degrees. And then the colors would be wrong, but they're still in phase. Unless this phase doesn't match, these are generated differently. But they are turned on here. I don't think that's what that is. I mean, I can go look. That would be on the timing logic, probably. Maybe. I'm looking for C 3.5M. Where does that come from? Aha, look at this. So, yeah, we've got two different signals here that are inverted of each other coming out of this S175. We could look at it. Why not? Let's do it. Let's do that. So I need to do a thing where I turn the machine off because I have to move my probes while it's on, and its machine is grumpy and doesn't like that. So I need to be, hopefully this is a chip I can get to. It is in the B area, which should be accessible. This is pin or this is chip. Let's look at B12. Chip B12. Pin 6. B12. Pin 6. 1, 2, 3, 4, 5, 6. There we go. And so that's a nice synced 3.57 megahertz signal. It's noisy. That's just my oscilloscope probe. As you can see, as I jiggle it, it does different noisy things because the probe is ass. So let's go back to side. Let's check its complement and see if it's actually complemented or not, shall we? That is pin 7. So this should be its complement. And let's change. There we go. Interesting. First things first. The first thing that I can see is its complement isn't being driven at all out of this chip. You see that? And in theory, it should be. The B is getting nothing on it. I mean, it's getting a slight jiggle, but not much. Just nothing. So that's a thing. Interesting. Pin 2. Pin 3. I have that at the right voltage levels. Pin 4. Pin 5. Pin 6. Do I have the probe in like 10x mode? Or some like weird mode? There we go. Ah, there you are. Look at that. I think that's our problem. Pin 2 and 3. Yeah, that is our issue. So let's zoom in. That's our color burst signal right there, right? That is under that, or that is C35M bar. That's this right here. Now we can see this other signal, C35M with no bar, which means it is the exact opposite of this one. It should be inverted. Different from this one. The same but opposite. If we look at that, which is this pin here, it's not. They're the same signal. See when I put that on there? See that? We can probably adjust the position of that. Down. Same signal. It should be inverted. So that means that this S175 is bad? Maybe? Let's put it in color mode. Let's do an actual video test here. I think I somehow locked the machine up. I don't know how. Mucking around with timing signals. There we go. Yep. Video tests. I want to actually create a color signal on the screen. Yep. So that's a color signal. And so if we look at they're the same phase. They're supposed to be separate. Install an RGB to HDMI in your scope, please. Yeah, I need to do that. So let's replace the S175 and see if that fixes our color issue. Bench, which is this chip right here. And where do I find one of these? This other Apple III I have sitting right here. Let's see if this fixes our color. Okay. Let's see if this fixes it. So I need to be testing pin 6 again. 1, 2, 3, 4, 5, 6. We'll check pin 7. Ha! Look at that. The phases are out of phase with each other by 180 degrees, like they should be. Let's see if this fixes it. I may have been testing it wrong, but we'll see if it fixes it. Nope. So I must have been testing it wrong. Okay. Well, it's a good thing to check. The color's still pink. It should be orange. Weird. Weird. Nope. It didn't fix it. Didn't fix it. How do I run a RAM test on the Apple III? Okay, so the quickest and easiest way to run a RAM test just means you don't have to fix something later in the repair process. Yes. The easiest way to fix or to run a RAM test on the Apple III is like this. I will show you. If you have the entire board out or have access to the keyboard or something, disconnect the keyboard from the computer. That's it. Or you could even pull the keyboard light out right here. Because what that'll do is that will tell the Apple III there's no keyboard installed. It will think it's on the bench in test mode. And you will get the test sequence on the screen like this. Without the keyboard connected, this is what you get. Right? You'll get this test pattern. So like an Apple IIc or an Apple IIe, yep. Same process. It's detected slightly differently. On the Apple III, they actually use like gating and logic and stuff. Whereas in the Apple II, they just check to see if the keyboard, they check for the presence of the open Apple key or the closed Apple key. But yeah, and it'll just sit here and loop indefinitely. And that diagnostic RAM, it's not super in depth. If you want a true full test, you need to boot the machine to the confidence test disk or the Apple II dealer diagnostic test disk and run the RAM test. So this chip wasn't bad. Well, poopy. Someday I will test this Apple III I bought years ago. Do it. Do it. Do it now. I'm very curious if I were to hack this Apple III. To give it the other C35M signal, if it would fix the colors. Just like it was designed wrong, maybe? It was sold as it was working and then smoked and smelled awful. So at least I know the refo's already done for. Ha-ha! Joe, could it be your adapter that's causing the issue? No, because the colors on my other Apple IIs through that adapter are fine. Or my other Apple IIIs are fine. That's not the problem. Also, we can get color out of the actual black and white jack in the back of the thing if you use the correct monitor, mainly because the circuit is so noisy, it bleeds enough color burst that you can get color. We'll see if I can get it to do it on the actual TV here. See, I mean, I'm getting, this is supposed to be black and white, and I'm getting like color noise, right? So let's boot it up and run that video diagnostic. Design wrong? Apple never made engineering mistakes. Butterfly keyboard. Butterfly keyboard. So we want to do the video tests. Yep, see, it's washed out, but it's still pink. Pink instead of orange. That's supposed to be orange. The cool thing about that is the light on that is red. Anyway, super high res. Let's get to the there's the color test, and you can see it here. Well, it's kind of hard to see, but I'm going to go to auto white balance, and then the exposure to kind of get this. It's hard to see, but that's supposed to be orange. Maybe less light in the room will help it. That's supposed to be orange. It's not. It's pink. That's supposed to be green. It's not green. It's yellow. It's just, yeah, it's not correct. So we can tell here, even through here, where we're literally just getting color bleed from the NTSC, or from the board being noisy. Hold on, I'm trying to adjust the. It's still not, the color's not right. That's supposed to be blue and it's green. That's supposed to be yellow and it's like orangey. Like it's not, yeah, it's not the adapter. And also, it's definitely not the adapter because the adapter is unplugged. It's not even plugged into the machine. So yeah, that's not the problem. But if we go ahead and switch back to the adapter while it's live, which we can do, unplug this, plug this back in. Now we have good color, but still, that's pink. It's shifted. And that's like orangey. And they're just all wrong, 100%. Across the board. And this is being generated, this is my RGB adapter. This is just the raw NTSC signal coming out of the board. So, I don't know. I mean, it's okay. I mean, it's close-ish. I don't know. What happens if I plug a floppy drive into the unused pass-through connector on the internal floppy drive? You will have plugged in a floppy into the internal drive. I don't know. I haven't looked into that. I don't know. White and black look okay. Yeah, they look great. They're beautiful. You're beautiful. Change the exposure to get rid of the. There we go. Yeah, I don't know. Well, that's all I'm going to do tonight. That's all we're doing tonight. I pretty much got it working. That color aberration, I'm not going to worry too much about. Are they still using the NTSC artifact color system in these? Mostly, it is a little bit better on the Apple III, but still not perfect. Because on the Apple III, they're not just using artifact color exactly. They also are incorporating a Luma component. So the dark green there, for example, is actually a darker color. Let me show you. Let's see how I can show you. Let's go to the schematics. I'll show you. This will require understanding a little bit how NTSC color is generated. But this is this is the signal mixer right here for the NTSC color. And this right here is what is in training. It's called the pixel train. That's what I call it. And this is what's in training all the pulses that go to the screen that are pulsing between 0 volts and 1 volt. Generally speaking. So your sync pulses are going to be negative going pulses that will pulse to 0. And then this is where the actual color data comes from. And that gets sent out to the screen based on relative positioning to some extent. But this doesn't actually generate color exactly. It's hard to explain. These colors have a phase shift, and this may be actually what's causing the phase shift issue. These colors have a phase shift relative to when in the signal path they're being generated. So these help actually generate the colors. And you can see they're just passing through some resistors there to just like lower their maximum value or whatever. And NTSC-A and NTSC-B are helping futz with that Luma. So what's happening is these are actually generating the brightness and the pixel itself. They're being pulsed to the screen. Like say, let's just assume RGB1 is red, right? If you look at our RGB signal, it pulses out red, then green, then blue, then this would be, I don't know, extra Luma signals. It sends those out in sequence. It's a serial bit train. These are helping determine when those go on the screen, if that makes sense. Not exactly, but kind of. I think I'd have to study it more, but basically, yeah, this is the Luma component. And then the chroma component is being overlaid by this. And then color actually shows up when when this is turned on to tell it when to do the color burst, when this is turned on to tell it not to kill the color, and then when this actually sends a color burst pulse. That's very generally how it is. So it is NTSC. It is still artifact color because it's sending pulses relative to the phase of the color burst. But it also is in training raw Luma data, if that makes sense. Similar to the way this is doing it. It's, yeah, anyway, it doesn't matter. So yeah, basically it's artifact. Yeah, that's it. That's all I had to say. Oh, for the most part, we got it running. The Apple III Plus is functioning. It works. I may want to play with that color phasing at some point. I would love to take this pen and lift it entirely and feed the C3.5 positive, not the C3.5 negative, and see if that fixes the color. That would be super interesting to see if that does that. But it's late, and I don't have time to do that tonight. So that's all. Yeah, so we got that fixed tonight. Thanks everybody for hanging out with me today. All 20 of you or so who stopped by, I do appreciate it. If you liked what we did tonight, or and our cool little fun that we had diagnosing this Apple III and digging into like how NTSC color works and why chips are bad and why chip testers cannot be tested and all of that stuff, or can't be trusted, hit the like button. And if you're not subscribed, hit the subscribe button and all of that. Because what that does is that tells YouTube, hey, this guy's cool. And it helps promote my channel to other people who watch content similar to the other content that you watch that's not mine. That's basically how that works. So it tries to find people that are like you, and then it suggests my content to people like you who don't know about my content. That's what the likes do. And then that's really cool. If you want to support me or my cool museum and all my shenanigans, which gives me the money to go out to eBay and pay way too much money for a new in-box board. You don't want to know how much. It was way too much. You can go to Patreon and drop $1 in the cup. That helps. That also gets you access to my patron Discord. And we just kind of chat there, and I kind of tell you what I'm doing in the background and stuff. So that's cool. Stop the press. I'm here. Javier, I'm ending the stream. You're too late, buddy. Can we call our own basements a museum? Yes. Yes, you can. Do we get any government museum benefits? That would be cool. You can also go to jcm-1.com and pick up cool things like my encoder chips to replace your broken keyboard encoders, or my my RGB adapters to allow you to plug your Apple IIIs into VGA with another adapter, or into a CGA right here, CGA monitor, or other options like that. Javi, you're so special. He is stopping the stream. Yes. And if you want to follow me on social media, you can follow me on Mastodon down there, Museum Joe, L Byte Spot Space. You can also find me on the Trash Fire, where all the twits go, at Museum Joe, if you want to follow me there until that falls over and dies. I will probably be seeing you very soon in the upcoming Retro Repair Roundup, and you'll be hearing from me on a lot of other cool projects in relation to the Apple III. Lots of cool stuff happening. So keep an eye out for that. Again, thank you to all the people in the chat who stopped by to hang out. Again, remember to hit like and subscribe, and we'll see y'all later. Bye, everybody.